Okay, hi everyone, and welcome to CG Buildup. And today we're going to be starting this first part series of this motion along the spline. This is the first part. We'll be making the curvature of the spline where the chains will be moving. So without any further ado, let's begin. So I'll have these items here, which I will share in a blend file, where we got the rings, the distance line, some two chains, this one here and the one in the middle that will be connecting, and after that you'll be able to follow along, and I will share this blend file with you. Hopefully you'll be able to follow along. So by starting, I'll just hide them for now. I'll click the collection, and I'll just add in a plane mesh, and this plane mesh, I'll just call it the system itself. Everything that will be encompassing these chains, some other stuffs including empties. So for example, I'm going to add in an empty plane axis, and I'm just going to add it, keep it there, then duplicate it to somewhere there. Actually, these two empties, I'm going to move them to a new collection, which is going to be called structure control. Structure control, which will be controlling the structure of the whole system, and we'll be seeing that soon. And to make it more interesting, I'm going to just scale one of the empties to be bigger than the other one, and that's all you're going to be needing in this tool. So I'm going to click this system, go to the geometry node workspace, reduce the spreadsheet. I'm going to look from above, and I'm just going to click this system, pin this, but before pinning, let me just click new, change it to motion, change the name to motion along the spline, just like that. And then I can pin this, and I also prefer to pin over here as well. And actually won't be needing the group input, rather we're going to start by this structure control. I'm going to keep it here, set it to relative, separate children because we need more than one instance, and just like that. Now I can just mute that there. Then I'm going to convert these instances to point to instance, to point, like there. And I want, no matter where the empties are going to be, the resulting points will always be flat on the z, meaning that they don't have any value, either greater than or less than 0. So I'm going to add in a set position node, and I'm going to multiply the position by 1 in the x and the y, and we might not be seeing them for some time, but if I just instance on points, okay, and our instances will be mesh cycles, just like this, mesh cycle, like that, and you can clearly see there are two of them here. Now what I want these mesh cycles to have is that they should adapt to the scale of these original instances from this collection. So what I'm going to actually do right now is add in a capture attribute node, connect it there, and here I'm going to add in an instance scale, connect the scale to there, and connect this one to the scale in this resulting instance. And actually, instead of being point, because the original instances, keep it to instances, and there we go. They are sort of mimicking the original. So if I see, if I select this empty, increase it in a way, we can see something starting to happen. Okay, so that's the concept. So the next step is I'm just going to realize these instances like that, and I'm going to now sort of do a convex hull, and add in a convex hull. Here it is. If I go here, I get something like this, which looks pretty cool, but I normally like to prefer to do it this way. I give this some circles some thickness first, whereby I'm going to extrude this mesh, and I'm going to extrude the edges, and the offset I'm going to connect in a vector, and type in one there and connect it there, and now it will have a little bit of thickness, and just like that. And the good part is, if I grab one of the empties and grab it not so high, it will still be flat, rather than if I could allow that even if I accidentally do this, something to happen. If I like mute this flattening thing, I mute it, it forms this structure, which won't be actually good in the calculations, because I mean actually the forming of these chains along that spline, because normally these chains, for example in water tanks and uh in bicycles or some machinery parts, especially in the industry, they're normally in a flat, fairly flat surface, I can assume. So that's why I need to flatten them like this, and it's good. And what we can do now is separate the face at the bottom. I prefer this way more than not doing this completely. Then so what I'm going to do right now is just on adding an attribute statistic node and set this one to faces, this one set them to Z, and connecting the position, and I want to say which face has the minimum Z position, and that face is the one that we're going to be separating using the separate geometry node. Connect it there, set it to face, and here we go, the flat face that we were in need of. And we actually don't need the face at the moment, so we're going to add in a delete geometry node, and we're going to set it to face and only faces. And if you connect there, we can see we get something quite beautiful, right? Let me just flatten out this empty, and we can see if I duplicate this like shift D, go somewhere here, we still get the structure, right? Anything that is in the middle won't contribute to the structure unless it, you know, its size sort of touches outside, and something like that, cool stuff. But let me just keep it fairly simple, and I don't really like seeing the cursor normally when I'm doing geometry nodes, so remove that cursor. So the next step will be converting this to a curve, and for what we're going to do, actually, we really need to control where the end point and the start point of a curve are going to be, because we're going to use the trimming of a curve to form that animation, and we're going to actually need to control the motion later, and we really need to know where the end point is always going to be. So this is how we're going to do it. So I'm just going to grab this group output there, and I'm going to here connect an attribute statistic node again, and this time we're going to ask from the point which point has the highest position along the x. Okay, and I'm going to correct equal to and connect it here just like that. and in most cases we can only get one point that has the highest value of in the x position, but sometimes they can be two. So I prefer normally to do like an accumulate field node, and we connect this result to the group ID and say which one in the trailing has equal to 0, so that always only one is chosen. And we connect this initial result, and just like that. And what we're going to do is we're going to save this boolean, and we'll see why. So I'm going to add in a capture and something like that. Connect this boolean here. I like how we don't have to change whether to point, then later we just change to the attribute to it. It's really cool that they have this socket here. So what next is we're going to extrude. Okay, extrude mesh. There we go. We're going to extrude the edges. It looks awkward, doesn't matter at all. What we're going to add in next is a split edges, and we're going to split this origin one here to there, just like that. Then afterwards we're going to delete geometry, and we're going to delete the top, and in so doing, and let's just convert this into a curve, then we add in a trim, and we connect it here, and in so doing we have made the endpoint to be and the start point to be somewhere here in the start. That's why if we start trimming, we can see there's a point over here where we start trimming again, going this way. And this trimming here is what we're going to use for the whole animation, and this is actually going to be really useful throughout. So let me just give it some room here. I'm going to talk about why am I giving it some room here a little bit in the end, but let's just focus on the animation using this spline. And we're going to be using rather this length factor than the factor, because we want to keep speed, and later we'll have to add the wheels, and we want the speed to also control the chain movement, also using the same speed parameter to control the wheels. It makes it easier, so that in the end we get a more realistic motion. Okay, so and I'm going to duplicate these two, and I'm going to shift control D. Here I'm going to connect a reroute, and here if I connect it here to the start, then in the one at the bottom I have to connect it to the end, and here in the end, in the one that I connected to the start, I should make sure its end here reads the spline length, and just like that. Okay, and I'm going to join these two. Actually, let me first just show you something. If I connect in here a value node like this, and just start trimming here, we can see a certain portion of here has been trimmed already. But if you go at the bottom, okay, we can see that portion that has disappeared on top is the one that has reappeared here. So if we join these two splines here by merging this point at this point here, we can sort of form a spline whereby its endpoint, okay, like this one here, is sort of moving, okay, with time. And that is going to be very essential later on, when we are going to be trying to sort of trying to make that motion of the spline and sort of the chains, whatever, That's going to be very important because later we will resample it. It's going to be more realistic, as in it will look as if there's chain, sort of chain movement happening. So let me just show you. So what I'm going to do right now is just add in a join geometry to join these two splines here, and in here I'm just going to add in a map range node. Okay, so in this value here I'm going to add in a scene time, and I'm going to connect seconds, not frames, whereby 0 0, but when 1 second passed, how much along the spline will be trimmed, that is like saying speed. So in here to min, I'm going to connect in the group input just like that, and I'm going to rename it, and I'm going to call it speed like that. Okay, then I'm going to sort of make sure it's not clamped. That's going to be very important. And in the result here, I'm going to modulate it, flow modulate it, and we're going to sort of flow modulating using this spline length. So I'm going to just duplicate it here and connect it to somewhere there, and connect this to there, where it's going to be fed into the start and the end for the bottom. Now if I play this, okay, there's nothing happening, like we can't see anything happening, but actually in here there are two endpoints that are keep moving along this sort of spline that we're seeing, although they're actually two. So we're going to make it one spline, but its endpoint, it keeps moving with time, and we'll see to it. So to make that possible, okay, we're going to sort of capture two attributes here and here. So I'm going to capture an attribute here. For here, I'm going to capture the endpoint. Here, I'm going to connect the actually for the top, since we're not trimming the end, okay, the one which is moving the start, so we have to actually capture the end, not the start here. And for the bottom one, we're going to also do the same, but because we not trim the start, that is what we're going to be capturing. So endpoint selection, capture the start, and we're good to go there. And what we are going to do next is convert this into a mesh, just to merge it by distance like that. And if you leave it like this, then the work done will be, let's just say 0, because not only the endpoints that are going to be merged are not the ones we intended, so we actually have to connect to say that this should either have this attribute or this attribute in order to be merged. And it's going to be like this, and connect there. And now if we sort of convert this to a curve, mesh to curve, and maybe we can do something like instance on points, connect it to the group output, in the instance connecting some icosphere, and maybe here we can type it 0.1, and if we play, we can see there's this icosphere that keeps moving with time, and actually something feels wrong, because the speed is actually 0, is supposed to be written at least 1. Yeah, so let's check what's happened here at the back. Yes, instead of connecting to the 2 min, I was supposed to connect to the 2 max, meaning 0, write 0, but for 1 write the speed. So sorry for mistake that I made here. It's at this point before we trimmed. So what I'm going to continue doing is play, and you can see there's this point here that keeps moving with time, right? It keeps moving with time, and we can go and make it even faster, maybe typing 10 so that it actually completes the loop, and we can see it's moving like that. See, keeps going and going. But this is not the motion of a chain. The short magic in order to make it to look like the motion of a chain is very simple. It's just to resample this whole thing. Just resample it, even by 10, by whatever number that you are. Let me just write 20, and now if I play this, you can clearly see what's happening. Maybe now turn it down a bit. You can clearly see now what's happening. These icospheres are moving as if they have a certain chain motion. See, you can see like we're done with this, right? But actually it doesn't feel like we are. Let me show you why. See, right now it's moving in this direction here. Okay, if I play this, you can clearly see what's happening. It's moving in that direction. So if I go back to the layout and just play, if I grab this one and move it to somewhere here, you can clearly see now it has gone back to this anti-clockwise direction. This flight, if I move it here, it's going clockwise, anti-clockwise. You know, it gets annoying if you just leave it at here. It gets quite annoying. You just want it to move in one direction to choose, not that when you move somewhere it goes changes the direction. So what we're going to do right now is make sure it is we choose either by at default it's anti-clockwise or clockwise. Okay, and it only changes to clockwise or anti in another direction. Like for example, if we set it to clockwise, it only goes anti-clockwise if we type in a negative value in the speed. That is what we actually want. So how we are going to control that is going to be very simple. So what we're going to do here, go to the geometry node section, and remember this space here I said that we're going to leave. Actually, I already made it congested here at the bottom. Let me just move this here. This place is what we're going to deal with right now. So I'm just going to move these ones to the side, just like that. And what we're going to do right now is very simple. We're just going to add in a switch. And that switch is going to sort of reverse everything if things go not the way that we want. And how is it going to know that it doesn't go in the way that we want? That's also very simple to guess. So we're going to add in an evaluate node, and evaluate at index like that, and we're going to evaluate the position along the y. This 0 is the position of the start along the y, and we're going to connect in here the position, and we're going to add another one of the same kind but along the one. Now if we want it to go always in a clockwise direction, I believe we should always make sure that if this value here becomes less than, actually if this value here becomes sort of less than, I believe, than this, if not greater than, it's one of them, then it should be reversed. But if I connect it here, this is what happens. So it needs a cycle here, and I didn't know what to do than this method whereby I connecting a sample index, and then I connect this value, can change it to boolean to there, then I connect this one to the switch, and right now if I play, it goes in this let's say clockwise direction. But if I type in here -5, and it now goes in a negative, in an anti-clockwise direction, and this is essentially what we actually want. And before so this is where I actually have to end in here. But before we go on, I think I have to make it a little bit smoother, and the best way to do that I found out is actually before the resampling. Actually, like, I want you to not actually, just set this one to be a Bezier curve. So set it to Bezier, which is set spline type to a Bezier. Then set the handle to be auto and connect it to there. Actually, also set the spline resolution to be something like even 30. That can be okay. And connect it here. The higher the better, actually, for smoother. And there, we play this, we get this sort of chain motion that you're seeing here. These icospheres moving. And yeah, I think that's the end of this first part of the tutorial series. I hope to see you in the next one. Thank you. If you like the video, subscribe, click the like button, comment, and see you on the next one.